Page 619, lesson 10.2 is on simplifying radicals. So radicals, we've got something maybe under a square root. Okay, anything that's got like a square root symbol in it that has a radical in it. And so what we're going to try and do, one of the things we're going to try to do in this lesson is we're going to try to simplify radicals. So you can see on the left side here are some examples of radicals that are simplified. On the right side are some examples that are not simplified. And so how do we know if they're simplified or not? If you just look at these points here, these are the ways that a radical is not simplified. So if there are perfect square factors other than 1 under the radical or under the radicand, then it's not simplified. Also, there shouldn't be any fractions, and also we shouldn't have any radical in the denominator. So we're going to go through and figure out how we can simplify something if it's not simplified then. So if you look at the bottom of the page, this take note box, basically it says if we have a square root of something, we can split it up as factors. So it's something times something, we can split it up as square root of a times square root of b. And then if one of those is a perfect square, then we can factor that. So a little bit easier to look at with the number example. If we have the square root of 48, we could break that down as 16 times 3, which the book didn't show just this first step. You don't have to do this, but just so you understand. That's 16 times 3, and then we can actually split it up as the square root of 16 times the square root of 3. The reason we might want to do this is the square root of 16 is a perfect square. Square root of 16 is 4, and now we have 4 times the square root of 3. Square root of 3 is not a perfect square, and we can't factor out another perfect square out of that. So this would be our simplified version. Sometimes also whenever you have something like this, there might be multiple ways of doing this to simplify it. So like square root of 48, if you were looking at that and thinking, you know, I didn't see the 16 there, I saw 4. And you said, well, I would do square root of 4 times square root of 12. Okay, that's fine. Square root of 4 is 2. And then what we have to do is just look to see whether we still have something we can factor here. So square root of 12, we could factor as square root of 4 times square root of 3. And then again, square root of 4 is 2. And then 2 times 2 is 4. So if you'll notice, we got the same answer. It just was an extra step to get there, and that's fine. It doesn't matter how many steps it takes to get you there as long as you get it simplified in the end. So if you look at problem 1, they want us to simplify the square root of 160. So 160, you might notice there's got a 16 in that, so we could break that down 16 times 10, and then square root of 16 is 4, and then square root of 10 we'll just put in behind that. And 10 we could break down as 2 and 5. Neither of those are perfect squares though, so that would be our simplified answer. So let's look at the got it 1. They want the simplified form of the square root of 72. So again, there's different options we might have here. Once again, 72, one option you might think of doing is 9 times 8 to get 72. 9 being a square root of 9 being a perfect square. So square root of 9 is 3. And then if you'll notice here, square root of 8 actually has a perfect square in it yet. We can do 4 times 2, and then square root of 4 is 2. 3 times 2 is 6. So that'd be 6 times square root of 2. Another option we were talking about here was you could do square root of 4 and square root of 18. And then 18, we could do 9 times 2. And then if you'll notice, both of those ways didn't get us right to the answer. And that means there's potentially was a bigger perfect square that we could have done. And that would have been 36. So square root of 36 times square root of 2. Square root of 36 is 6. And that would give us the same answer. And like I said, I don't care which route. There's 3 different routes here we could take, and all of them get us to the right answer. So any of those ways would be correct. So as you might have expected, besides just numbers, we are going to be looking at problems that have variables in them as well. So if you look at this on problem 2, simplified form of the square root of 54 n to the 7th power. So what we have to do is we have to factor not only the number part, but also the variable part. So with 54, they factored that as 9 and 6. And then basically with the variables, what we're going to try to do is we're trying to just look for the biggest even number that's less than or equal to this exponent. So we have n to the 7th power. If it's an even number, we'll just take it. If it's an odd number like this is, we'll go just one below that. So that would be n to the 6th. And they broke it up into the 6th and n. Remember, n would be like n to the 1st. And if we would multiply n to the 6th times n to the 1st, that would be n to the 7th. The reason we want to do that is because the square root of n to the 6th is going to come out evenly. In other words, what can I multiply by itself? And you can split this up if you want. What number can I multiply by itself to get n to the 6th? And that would be n cubed. N cubed times n cubed, multiply like bases, add the exponents. That would be n to the 6th power. And then this stuff is kind of just our leftovers that didn't factor out evenly. So that would be our simplified answer, which matches up with choice C. So the got it too, they're asking what the simplified form of this is. One thing a little different on this one you might notice is there's already something out in front of the radical, and we're just going to rewrite that. We're just going to bring that down, and then we're going to try to look for what kind of perfect square stuff do we have, and then what kind of leftover stuff do we have that's not maybe perfect squares that we're seeing. So with the 80, you may or may not see this, but 80 we could break down as 16 times 5. 16 is a perfect square, so I'm going to put that in this first radical here. With m to the 9th, it's an odd number, so we're going to go with an even number that's just below that. So just below 9 would be 8, and then that leaves us 1m back here. With the variables, either everything's going to come out in the front part if it's even. If it's odd, we're only going to have just a plain letter in that second square root. And then at this point, if you want to, you can break this up as 2 separate square roots. You don't have to, but just as you're learning here at the beginning, might not be a bad idea to look at it that way. So to simplify this then, square root of 16 is 4. Square root of m to the 8th would be m to the 4th. And then just one more little thing here to simplify this. This m is like m to the 1st. I'm just going to rearrange things. So I've got a negative. I'm going to go ahead and put the number 4. And then if we multiplied m to the 1st times m to the 4th, that would be m to the 5th. And that would be our simplified answer. And again, if you didn't see 16 times 5 at the beginning, another option, you could have done 4 and 20. And then you could have seen 20 was 4 times 5, and it would have worked out the same way. And if you were doing it this way, always in the front, we want to have the perfect square. So if you break it down as 4 and 20, you want to have the 4 in the front, not the 20 in the front. And then with the variables, you can probably see that m to the 8th would need to go up there. And then square root of 4 is 2. Square root of m to the 8th would be m to the 4th. And then back here, the 20 we could break down as 4 times 5. And then this last radical is always kind of the leftover stuff that maybe we don't see as a perfect square, or maybe it's not a perfect square. And then, well, I lost my negative sign here in the m that they had in front of it. But you can see that would work out the same way. If you look at problem 3, what they're talking about in this problem is that instead of trying to pull things apart, we can actually multiply them together. So if you look at problem 3, they're wanting the simplified form of this. And right now it doesn't look too great. Under that first radical, we've got a 7t. 7's not a perfect square, and I can't factor out a perfect square out of that. 14, same thing. I can do 2 and 7, but neither of those are perfect squares. What we can do, though, is we can actually multiply these together. So you can see that's what the book's doing here. So they went ahead and multiplied these together. We can bring them back together just like we can take them apart. And when you do that, you've got square root of 98t cubed. 98 is probably not a real common number for us to look at, but if you look at this, we had a 7 and a 14, so you might notice both of those had a 7 in common. So those both had a 7 in common means we have a 7 times 7, or 49, that we can pull out of that. So that's what they did here. And then square root of 49t squared is 7t. And then the other part just stays back there, and then we multiply by the 6 that was in front. The other thing you could do, kind of a different option here if you want, is when you look at this, you could look at this and try to see factors that are in common. So with the 7 and the 14, you might say, well, those both have a 7. So we could do, I'm just going to ignore the variables for a minute. 2 times 3 is 6. And then over here, I can factor that. And then I can say, okay, I've got 2 square roots of 7. If I multiply those together, that would be square root of 49, which is going to be 7. These pieces are going to be kind of the leftovers. And then square root of t squared would be t. So that's a different approach. Rather than multiplying and getting a big number, you can try to look for, is there a repeated factor that I can find in common? And then I'll just multiply those together and get a perfect square instead of having a big number and trying to break it down further. One thing when we're doing these problems, I haven't mentioned it yet to this point, but when you're working these out, generally the rule is that the stuff that comes out evenly that's not under the radical we'll put first. And technically we could put it like this, but that's not normally how it's written. And I think part of that, the reasoning there is that let's say we had different variables, and let's say we had, it was a times the square root of 5c. And so if I put the a in front versus putting it behind, sometimes depending if we're sloppy on this at all, if it was behind it, it might actually look like it's under the radical. Whereas if it's in front, it's clear that it is not under the radical. So that's the reasoning why we put the part that's not under the radical first. So if you look at the got it 3, they're wanting us to simplify these. So part A, again, if you want to try and look at, and this one is actually different than the one we just looked at, because this one, if you'll notice, the 6 doesn't have anything that can work, but the 18 does. So actually, if you want to break that down first before you start multiplying things together, that'll give you smaller numbers to work with. So if we do that, we could do square root of 9 times square root of 2. And then we know square root of 9 is 3. And then we can look at these other two pieces now. We've got square root of 6 and square root of 2. And neither of those are perfect squares. So we can go ahead and multiply those together. 6 times 2 is 12. And if you want, we can go ahead and say 3 times 3 is 9. So square root of 12 then we could break up as square root of 4 times square root of 3. And I'm just doing it this way because then I've got my perfect square in front. Square root of 4 is 2. And then 9 times 2 is 18. So 18 square root of 3 would be our answer for that one. So if we look at part B, similar idea here. Whoa. So this one again, the second radical here happens to have a perfect square under it. So if you want to go ahead and pull that out in front. We could also, out of the a to the third, we could pull out an a squared and leave an a. Since I've got this other a over here, I'm just going to leave that because I'm going to have to clean it up later anyway. So square root of 9 is 3. And then if you want to, we can go ahead and just multiply these together. So that'd be square root of 2a to the 4th. And then square root of 2, there's nothing we can do with that. So since the a to the 4th, that's an even number, that can be factored out. Square root of a to the 4th would be a squared. A squared times a squared is a to the 4th. And then that would be our answer. Going back with part A, if you would have done this differently, let's say you didn't look at that and say you didn't split up the 18 as 9 and 2. If you just multiplied those together, that would have been the square root of 108, which is a pretty big number that we're probably not real familiar with. What you can do if you're not sure how to break that down, one thing, like I said, if you had a calculator, you could just keep dividing by perfect squares until you get something that works. Another thing is you can do a factor tree and see how it breaks down. So maybe I have no idea about 108. I'm breaking it down. Okay, it's even. So it's 2 times 54. And then 54, oh, now I see 54. That would be 9 times 6. And then I can see there's a perfect square that I could factor out. And then these other parts we can multiply together to be what's left underneath here. And then, oh, square root of 12, I could do 4 times 3. So just something to think about. If you have a big number, you can think about a factor tree to maybe help you with that. Okay, over to part C. These numbers in front, I would probably go ahead and just multiply those together. 7 times 3 is 21. And then you can try to work with this. With the 20, you might say, oh, 20, it's got a 4 in it. And that's fine. But if you'll notice what's going to happen if we multiply these together, 5 times 20 is 100. And that's a really nice number. So I'm actually just going to do that. I'm just going to multiply those together. And then that's going to actually make it easier for me. So we can break this up. Square root of 100 is 10. Square root of x to the 6th would be x to the 3rd. And then if you multiply 21 times 10 is 210. So that'd be 210x cubed.